Every engineer holding back a heavy freight on a long mountain descent in the 1950s knew the same anxiety in his cab. The diesel locomotives at the head end were doing their job pulling the train. They could not, however, easily slow it. The dynamic capabilities of the new diesel-electric units were oriented toward producing power at the wheel, not absorbing it. On a long descent, the engineer had two options. He could ride the train brake, holding the air application steady through every curve, until the brake shoes on every car of the consist were hot enough to fade, the same problem that had been killing truck drivers on mountain grades for 40 years. Or he could use a tool that the diesel locomotive itself had quietly made available. This is the story of the dynamic brake, the system that turned the locomotive's own traction motors into a way of slowing the train. The diesel-electric locomotive by the early 1950s had largely replaced steam in American mainline freight service. The arrangement was straightforward. A diesel engine in the body of the locomotive turned a generator which produced electrical current, which drove traction motors mounted on the axles, which turned the wheels. The system was efficient, reliable, and it had a property that the engineers who designed it recognized early. A traction motor is mechanically the same machine as a generator. Apply current to it and it produces torque at the shaft. Apply torque at the shaft and it produces current. The two functions are reversible. If the locomotive's traction motors could be wired on command to operate as generators rather than as motors, the rotating wheels would drive them, and the energy of the train's forward motion would be converted into electrical current. The current had to go somewhere. The solution was to route it through a bank of resistor grids mounted on the roof of the locomotive, where it would be dissipated as heat into the air through powered cooling fans. The energy of the train's momentum became heat in the locomotive's roof, and the train slowed down without the brake shoes on the cars ever being applied. The system was called dynamic braking. The first widespread installations appeared on Electromotive Division Road locomotives in the late 1940s, and became standard equipment on most American freight units by the late 1950s. The engineer activated the system through a separate handle in the cab. He could select the level of braking force he wanted, and the system would maintain that force as long as he held the lever in position. On a long mountain descent, a properly equipped freight train could be held at a steady speed using dynamic braking alone, with the air brakes on the cars released and ready in reserve for an emergency. The advantage on the brake shoes was substantial. The advantage on safety was greater. A dynamic brake produced no heat in any component on the freight cars themselves. It could be sustained indefinitely. It did not fade. The same descent that might have produced a runaway under sustained air braking could be handled by an engineer working the dynamic brake correctly, at a speed of his choosing for as long as the grade ran. The system had limits. Dynamic braking weakens at low speeds because traction motors generate less current as their rotation slows, and below about 10 miles an hour the dynamic brake provides almost no retardation at all. The engineer still had to set the air for the final approach to a stop. The resistor grids and their cooling fans were also expensive to maintain, and a failure of either the cooling system or the grids themselves could disable the dynamic brake entirely. But within its operating range, the system was transformative. By the 1980s, dynamic braking was standard on virtually every road locomotive built for American service, and the grade descents that had once required the most experienced engineers on a railroad's seniority list could be handled by a competent crew working a system that did most of the work for them. The dynamic brake did not eliminate the air brake. Every freight car still carries a full air brake system, and an engineer descending a long grade still uses both. But it gave the man in the cab something the steam-era engineer never had: a way to slow a heavy train using the same machinery that pulled it up the grade in the first place.